Hello and good evening, CSI257 Section 847 students. For the first 8-week session at Anne Arundel Community College for the spring 2015 semester. This evening's PacketTracer tutorial will be on PacketTracer Activity 2.3.2.2, where we're going to take a look at configuring Rapid PVST Plus. And so if you take a look at this activity, you're probably going to notice that it is almost identical to the activity that we did previously in 3.1.5, where we configured just PVST Plus based on the original 802.1d IEEE spanning tree protocol. The Rapid PVST Plus is going to leverage the Rapid Spanning Tree Protocol, RSTP, and the mode will be RPVST Plus because we're going to be using 802.1q trunks, and so we'll talk a little bit about that. I've got my my pin has been fixed since the last video, so let's go ahead and talk about the differences between 802.1d, which is the original spanning tree protocol, right? And what happened was Cisco, this is a P here, PVST, and then you have PVST Plus. And so this used ISL for the trunking, and this uses 802.1q, right? 802.1q. And so when we talk about the traditional or the legacy spanning tree, we're talking about three different types of port roles, right? So there's port roles, and the roles are different from the states. So what three port roles do we have? We had the root port, we had the designated port, and then last but not least, we had the blocking port. Right? So those were our three port roles. Our states, so the port states with regular 802.1d IEEE spanning tree protocol, or what Cisco refers to as PVST Plus, because ISL is deprecated, right? So ISL is old. So what were the port states? So we'll take a look at the first port state we had was disabled, right? And this is if the port has been manually disabled. And then we had the second port state, which was going to be blocking. The third port state would be listening. The fourth would be learning. And the fifth was forwarding. And so along comes 802.1w with a lowercase w. And so I was actually asked about this the other day. Why uppercase and why lowercase? And so the way the IEEE does their standards, the lowercase letter means that the standard is an amendment to another standard. So 802.1 with a lowercase w was basically, it's a standard that was an amendment to another standard. And so then we've got the 802.1 with the capital D here, and the capital D means it's a standalone standard. So it's not an amendment to another standard. All right, so 802.1w, which is based on the Rapid Spanning Tree Protocol, and this is the IEEE, whoops, the I in here, the IEEE standard, right? Spanning Tree Protocol was the IEEE standard. And then Cisco took the Rapid Spanning Tree Protocol and said, you know what, we'll do Rapid, and let me get rid of that actually. So we'll do Rapid per VLAN Spanning Tree, and we'll do Rapid per VLAN Spanning Tree Plus. And again, this was if you were using ISL as your trunking encapsulation, and this is if you're using 802.1q. And so this is why you'll see references in legacy documentation to simply RPVST with no plus, and the same thing with PVST. And that's the only difference, right, between the plus and not having the plus after the name. And so these are considered, you would consider the modes, right? These are the Cisco modes. So we'll say these are your modes. And when you run the command spanning-tree mode, that's where you would elect, am I going to be doing per VLAN spanning tree, or am I going to be doing rapid per VLAN spanning tree? Okay, so what kind of changed? Well, it ended up that with respect to the port roles, right? We picked up a port role, in a sense. So now, with the RPVST plus, you've got the root port, and those are the same. You've got the designated ports, right? And that's the same. And now we've got what's called an alternate port, right? And in addition to the alternate port, we've got a backup port. And so this is why they say that rapid spanning tree can converge faster, because it has alternate ports and backup ports that are ready to step in and to transition to the forwarding state much faster than traditional legacy 802.1d spanning tree that would have to sit there and go through the listening and the learning. So those are the 4 port roles, and then you've got, again, you've got your port states, and it's been greatly simplified here. So it's down to 3, and the first one is discarding. Whoops. So you have discarding. Then you have your learning. And you have your forwarding, and that's it. Right? So those are the 3 states. Here are your 4 roles. And over here, with the legacy spanning tree, you've got 3 roles and 5 states. Right? So again, you should be using RPVST plus, or I should say rapid spanning tree protocol, if you're doing a deployment today, or even if you're upgrading, because 802.1d is definitely legacy, right? Or if you were using multiple spanning tree, right? MST, but we're not, it's a little outside our scope. We don't even discuss this as part of our curriculum. Okay, so again, we're pretty familiar with this. We've already seen some of the other commands, or I'm sorry, some of the other scenarios with these steps in it. So let's go ahead and jump in. It's going to say the first step is going to be enable the user ports on switch 2 in access mode. And again, very similar to the activity yesterday. However, here all of the hosts are on switch 2. So let's go ahead and configure switch 2. So we're going to go from user exec into privilege exec with the enable command, and then we're going to go into global config mode, and actually I need to do the terminal with config T. Okay, I'm trying to read the directions and talk and type at the same time. So let's we take a look at the topology diagram, and we are going to go ahead and put those ports into access mode, and they're going to be in VLANs 30, 20, and 10. So let's go ahead and we'll just start over an interface FA011. Right, so if I say do show run, we take a look at 011. You can see right now it's set up as a trunk port. So what we're going to say is switch port mode access. We're going to say switch port access, and FA011 is going to be access VLAN 10, and it should create it if it doesn't exist. And there we go. We're also going to say spanning tree BPDU guard enable, because I'm assuming we're going to be doing that at the bottom. And then we're also going to say spanning tree, and I'm going to say port fast. So we'll put port fast on there as well, just in case. All right, so that takes care of the first port. Now let's go into interface FA018. And we're going to say switch port mode trunk, and before I do that, let me go to 11 again, and I think it was shut down. It certainly was. Light was red there. So let's go back to 18. So I'll say interface FA018, and I'm going to say no shut. We're going to take care of that right now, and we're going to say switch port mode access. We want this to be an access port, and then we're going to say switch port access VLAN, And for FA018, it's going to be VLAN 20, and it's going to create it for us. We're also going to say spanning tree BPDU guard enable, and we're going to say spanning tree port fast. And port fast is, it's going to skip through any learning state, and it's going to go directly to the forwarding state for us. And we get a message that's telling us that that's exactly what it's going to do. And last but not least, let's go into FA0/6. I'm going to say no shut, switch port mode access, switch port access VLAN, and my guess is 30. Is that right? VLAN 30, okay. Say spanning tree port fast, and spanning tree BPDU guard. All right. So we've got those features taken care of. So let's create the VLANs now. So we're going to go ahead and say, let's exit out one level. We'll say VLAN 10 we've actually already created, VLAN 20, VLAN 30, VLAN 40. And I actually forgot to take a look yesterday to see if we could, if maybe I had, if I were to do, we've already got 10, 20, 30. So if I were to say 40, comma, space 50, comma, 60, I don't think that's going to work. Yeah. So we'll just stick with VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. Same VLANs that we had the other day. So then assign VLANs to switch ports. So port assignments are listed in the table. We've already done that. So verify the LAN. So we'll do a do show VLAN brief. And that's going to show us our VLAN table, and there are our VLANs. All right. And let's go ahead now, step 5. So it says assign the trunks to native VLAN 99. So I'm going to go ahead and say interface range FA01 to 4. And in fact, I'm going to have to create those VLANs on all of the switches, but let's knock this out first. So interface range FA04, so we'll say switch port mode trunk. And you can see there that the lines, the interface, line protocol and the interface has come up. And then we're going to do switch port trunk native VLAN 99. All right, let's jump over to switch 1 and let's start to get switch 1 configured up here. So no hosts on switch 1, so we can go right to the heart of things. We're going to go from user exec to privilege exec, and then into global config mode, where I'm going to say interface range FA01 to 4, and we're going to say switch port mode trunk, and then we're going to say switch port trunk native VLAN 99. And we're getting an inconsistency message, and that's okay. And I'm pretty sure these aren't shut down, so I say no shut anyway to make sure. And now let's go ahead and let's get our VLAN. So yeah, you can see we've got a native VLAN mismatch discovered with switch 3 because we haven't configured switch 3 yet. So I'm going to go ahead and say VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, whoops, VLAN 70, VLAN 80, and VLAN 99. All right, so the VLANs are all created. There are no user ports to configure here, and we've already set the trunk links up. So let's go ahead and jump on to switch 3. All right, so same thing on switch 3, from user exec to privilege exec into global config, interface range FA01 to 4. And we're going to say switch port mode trunk, and then we're going to say switch port trunk native VLAN 99. All right, then we're going to create some VLANs here. So VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, 70, 80, and 99. All right, so configure the management interface on all 3 switches with an address. And so the management interface is VLAN 99. So here are the IPs. Let's go ahead and set this up on switch 3. So interface VLAN 99, and we're going to say IP address 172.17.99.13, and we're going to be /24. And let's do the same thing on switch 2. So we're going to say interface VLAN 99 and IP address 172.17.99.12/24. And last but not least, switch 1, where we're going to say interface VLAN 99 and IP address is going to be 172.17.99.11 with a /24 subnet mask. So there is our management VLAN. So here we go. Part 2, configure rapid spanning tree protocol, or RSTP, which is IEEE 802.1 lowercase w. And so this is, again, you can go ahead and read this on your own, but basically what they're saying here is that 802.1d is your legacy standard, and RSTP is the next generation of the spanning tree protocol that was developed after the original legacy 802.1d spanning tree protocol. So how do we set the mode? We simply say spanning tree mode, and what are our choices? We want rapid PVST, right? And since we're using 802.1q trunks, if I do a do show interface trunk, you can see that we are 802.1q, so this will be RPVST plus, or rapid spanning tree rapid per VLAN spanning tree plus, right? All right, so we changed it on switch 1. Let's come over to switch 3, and we'll say spanning tree mode, rapid PVST, and let's get the same thing on switch 2. Spanning tree mode, rapid PVST. So now if I do a do show span, what we should see is that it doesn't say IEEE here like it did in our first video. It actually says rapid spanning tree protocol, right? So you can also see that we have the designated port, we have the root port, just like we did in 802.1d legacy spanning tree. You've got your designated port and you've got your root port, right? Very important that these are the port roles, right? Here, so it says right here, there's your port role, and that's the port states. And then we have the designated port, like we had, and then you've got this alternate. Now what's interesting is you'll see this, and let me pull up some actual Cisco switches here. And where are we at? I'm trying to find. And let's see here if I do a show spanning tree. Let's see what we get. I'm trying to remember. So here we go. So we're running just the regular spanning tree protocol, right? And we've got, I think, is that all the output there? Yeah, so that was, I think that might be the root bridge. I'm trying to see which one's got some blocking ports in it. Show spanning tree. Yeah, so you can see we're running IEEE. However, it shows the role as alternate, right? And so if you remember from the legacy 802.1d, where they said it was sort of a blocking port, right, where the role could be blocking. And the reason that you see alternate in here, even though it's IEEE, having done some research and talked to a few people at Cisco, the reason for this is that since the IEEE 802.1d spanning tree is considered legacy, they still put the newer information in here because it doesn't hurt anything, right? Because, again, it's blocking, so to say that it's alternate blocking, that's okay. You just need to understand that this is 802.1d spanning tree, so you're not going to get sort of the full effect of the alternate port state because we're not running rapid spanning tree protocol. And so what I wanted to show you is sometimes, or I shouldn't say sometimes, you will see this, right, as listed as an alternate port, even though it's IEEE 802.1d legacy spanning tree. So don't be shocked by that. They put it in here because it doesn't hurt anything, and if I were to convert this, and let's go ahead and say spanning tree mode, rapid per VLAN spanning tree, and then do show span, that is the role of the port, right? That would be the role of the port. So it doesn't hurt to put that in here, and that's why it's in here, because again, the IEEE 802.1d legacy spanning tree protocol is just that. It's legacy. So Cisco has decided to go ahead and put in the new port roles, even if you're running the legacy spanning tree. So that's why you see that here. All right. So it says configure switch 1 to be the primary route for VLANs. Again, we did the same thing yesterday for the odds. So let's go to switch 1. And how did we do that yesterday? So we said spanning tree VLAN 1, and if I'm not mistaken, we can do, yes, thank you. That'll be perfect. So 1, 10, 30, 50, 70, and I think that is it. And what we're going to say here is, remember, we have two choices. We could say priority and hard-code it, or we could just say root primary. And root primary, this is a macro that's going to actually run the spanning tree VLAN 1, 10, 30, 50, 70 priority 24576 command, and it's a macro. It's running it in the background for us. So we'll go ahead and enter that in. And as you notice, the ports on switch 1 all went green because switch 1 is now forwarding for these VLANs here, right? So all of these ports are going to be designated ports for the VLANs that we've identified here, right? And remember, simply by making a switch the root bridge, it doesn't mean that the switch is dictating the forwarding. It's a reference for the other switches in the topology for them to decide how am I going to forward my traffic, which ports are going to be forwarding and which ports are going to be blocking, right? So by making the switch the root bridge, it's not that the root bridge is telling other switches, hey, you're going to use this port to do this, and this port to, this is going to be a forwarding port, this is going to be a designated port. It's simply a point of reference for everybody else in the topology, and in this case here, for everybody else that has VLANs 1, 10, 30, 50, 70, when we set that command on switch 1, it's a reference point for switches 3 and 2 to now say, hey, here's the root bridge for these VLANs. I need to now figure out which of my ports is going to be the root port, which of my ports is going to be a designated port, and which ports are going to be blocking ports. And in our case, we'd be looking at alternate/backup ports, right? So again, making a switch the root bridge, it's not that the root bridge has some sort of hierarchical power over the non-root bridges. It is simply a reference point in the topology off which other switches will base their forwarding decisions for their ports for specific VLANs. Okay, enough on that. So now let me go ahead and go over to switch 3. So this is very similar to the activity for PVST plus, and so we're going to say spanning tree, and not mode, spanning tree VLAN, and we're looking at 20, 40, 60, 80, and is it 99 as well? And 99, and we're going to make switch 3 the root for these guys. So then we would say root primary, and away it goes. And then switch 2 is going to be the secondary for everybody. So spanning tree VLAN, and this is going to be a boatload here. Yep, so 1, 10, 20, and that was actually 31. Skipped at 10, 20, 30, 40, 50, 60, 70, 80, 99, root, secondary, right? So let's do a do show span now on switch 2, and you can see that he has set his priority to 4096 above the root bridge, right? And for VLAN 10, the root bridge is switch 1. So on switch 1, if I say do show span, you can see it says this bridge is the root for VLAN 10, and it's 24576, right? And so all switch 2 did was set his priority to 4096 above that in case for whatever reason switch 1 goes offline. Switch 2 for those VLANs will become the root bridge for the odd VLANs. All right, so we verified our configuration. So configure port fast and BPDU guard. We did that. And as we're talking here, I just noticed that down here in the corner, it seems like this may be hung up. It's actually, I've had this up for about 24 hours now. So it's possible that it's just hung up and it's showing 0. So we check our results here. Let's see if it gives us credit for anything. So yeah, so it is logging it. If you take a look there, we're looking pretty good. And we're missing one little thing. And what did I do? BPDU guard on FA06. So let's see if it updates the score here. Nope, but that's okay. So FA06 on PC, oops, not on PC3, on switch 2. Let me go ahead and say do show run. Let's take a look at FA06. And sure enough, so let's go ahead and go into interface FA06 where I forgot to say spanning tree BPDU guard enable. All right, let's make sure that we've got everything knocked out. And we do. We're at 100 out of 100. All right, so this has been PacketTracer activity 2.3.2.2, where we've been talking about rapid per VLAN spanning tree, or RPVST plus. And again, remember, it's the plus, and all the plus means is that the trunking encapsulation is 802.1q. And if it wasn't 802.1q, if it was ISL, which again you'll find on legacy switches but not on the newer switches, it would simply be RPVST. And in fact, I'm curious to see here if I were to say, let's see, I'm not even sure which connections I have here. So if I were to go into interface E00, let's see if we've got switch port mode trunk. Okay, so we have to say switch port trunk encapsulation .1q, switch port mode trunk, and then if I were to say, it was the switch port. This would be ITCH switch port trunk encapsulation, and actually, so this is 15.4 code, and ISL is still there. So, but again, ISL is definitely a legacy technology. You should be using .1q, 802.1q. Okay, well that wraps up our conversation about rapid per VLAN spanning tree and the rapid spanning tree protocol. And remember, the port roles, you've got 4 port roles, root designated, alternate port, and a backup port, and just 3 states instead of 5. Discarding, learning, and forwarding, as opposed to your legacy roles and states. All right, well, I really appreciate you watching. I hope that this has cleared up any confusion you might have had about the Rapid Spanning Tree Protocol 802.1w, how it compares and contrasts with the legacy 802.1d IEEE Spanning Tree Protocol, and the port roles and the port states and the similarities and the differences. All right, I will see you guys tomorrow morning. Have a great evening.